Question 1 is, a skier travels down a slope pitched 35 degrees below the horizon while traveling 30 meters a second. What are the horizontal and vertical components of the skier's velocity? So I drew this diagram. The line V, right here, is 30 meters a second. That represents his velocity. And X and Y are the vertical and horizontal components of his velocity. We know that V is 30 meters a second. This angle here is 35 degrees, so he's pitched 35 degrees below the horizon. And we know that theta is 55 degrees, because 90 minus 35 degrees is theta, and we know this is 55 degrees, and we know this is 90 degrees. So to solve this problem, we're going to need to use sine and cosine. Alright, this equation right here was for solving the horizontal component. We know that we need to find x. And to find x, we knew we'd need sine, because sine is opposite over hypotenuse, and the opposite of theta is x. And so the hypotenuse is 30. So sine of 55, which is theta, equals x over 30. So the answer to the horizontal component is 24.5 meters a second. The same with cosine, except cosine is adjacent over hypotenuse. Y is adjacent to this angle theta, so cosine of 55 equals y over 30. The answer to this is 17.21 meters a second. So these are the horizontal and vertical components of the skier's velocity. Question 2 is, a football player runs directly north for 18 meters before turning 35 degrees to the right. He then continues in this new direction for an additional 9 meters. What is the magnitude and direction of this player's total displacement? I drew a diagram to represent this. Here is where he runs 18 meters north, and then he turns 35 degrees and runs for 9 meters longer. We know here's 35 degrees, and we know this remaining angle here is 125 degrees. For this problem, we're going to have to use the law of cosines, which is x squared equals a squared plus b squared plus 2ab cosine theta. Here are our knowns. We know that a is 18 meters, b will be 19 meters, and our theta will be 125. And what we're trying to find is x. Here's the work all done out. In the end, we know that x is 11.81 meters, and that makes the final answer 11.81 meters with a displacement of 35 degrees, or with a heading of 35 degrees. Question 3 is, it takes a 12 Newton force to start a 7 kilogram rock sliding on a level surface, then a 10 Newton force to keep the rock sliding at a steady velocity. What are the coefficients of static and kinetic friction? These are the two equations we need to know for this. These equations find the force of static friction and the force of kinetic friction. Here are our knowns. We have the force of static friction is 12 newtons. Force of kinetic friction is 10 newtons. The mass of the rock is 7 kilograms. We know the normal force equals mass times acceleration, so 7 times 9.8 equals 68.6 newtons. So just plug our known variables into the equation, and we find that mu sub s equals 0.175, and mu sub k equals 0.146. Question 4 is, if the surface from the previous problem is now pitched up to an angle 50 degrees above the horizon, would the rock stay in place or would it begin to slide? If the rock does slide, what is the acceleration down the ramp? To illustrate this question, I drew a diagram. We have the 50-degree angle pitched up from the horizon. Here we have the 7-kilogram rock. We have the force of gravity pushing down on it, and then the force of gravity can be broken down into two components. The force of gravity perpendicular and the force of gravity that is parallel. We know that the force of static friction is also pulling up against the rock that way. Here are our knowns. We know that the force of static friction is 12 newtons and the force of gravity is 68.6 newtons. and we also know that theta equals 50 degrees. Now we need to find the force of gravity that is parallel. Here is the equation for finding the F sub g parallel. If you want to find the F sub g perpendicular, all you have to use insert cosine instead of sine. And so now we know that force of gravity parallel is 52.55 newtons. Next we had to find the net force, and the net force is equal to the force of gravity parallel minus the force of static friction. So we find that the net force is 40.5. If the net force was 0, we would know that the rock did not move. But because it is greater than 0, we know that the rock does slide down the ramp. The next part of the question was asking what the acceleration down the ramp was. So to find the acceleration, we know that the F net equals mass times acceleration. This is relatively simple because we can just move acceleration over and have F net over mass, sorry I meant move mass over, equals acceleration. And so we know that the net force is 40.55 newtons and the mass is 7. So 40.55 over 7 equals acceleration. So the acceleration of the rock down the ramp is 5.79 meters per second squared. Question 5 is, a child drags his 10 kilogram sled across level ground. What is the sled's acceleration if a child applies a 30 Newton force to the sled at an angle of 25 degrees above the horizon? Assume a coefficient of kinetic friction of 0.2. So right here is, I drew a diagram to help me think about it. Right here is the sled. The child is pulling with a 30 Newton force up at an angle of 25 degrees. The X is the horizontal component of his pull, and Y is the vertical component of his pull. Here I just quickly found the horizontal and vertical components of the child's pull. The horizontal component is 27.2 newtons, and the vertical component is 12.68 newtons. I did that using cosine and sine. And here we also have our knowns. We know that theta is 25 degrees, the mass of the sled is 10 kilograms. So the normal force is mass times acceleration, so the normal force is 98 newtons, and the coefficient of kinetic friction is 0.2. Here is finding the force of kinetic friction. It is 19.6 newtons. To help me think about this, to find the net force, here is just the horizontal components of the child's pull. We know that he is pulling this direction with a force of 27.2 newtons. Then we know the force of kinetic friction is going in the opposite way with a force of 19.6 newtons. Because of that, we know the net force is 7.6 newtons. Okay, so to find the acceleration of the child's pull, we know that F net equals mass times acceleration. So we know that the mass is 10 kilograms. If you do not know the acceleration, we know that F net is 7.6. So to find acceleration, all we do is divide 7.6 by 10. So the acceleration equals 0.76 meters a second squared. That is the acceleration of the sled.